Now we're going to page 2 of the first day slash really second day of differential equations. So we can express an nth ordinary differential equation, one dependent variable, by the general form f of x, y, y prime, all the way up to y to nth equals 0, where f is a real valued function of n plus 2 variables, x, y, y prime, all the way up to y to the nth order derivative. The normal form can be written as d to the ny, so that n just tells you the order, d x to the n, how many times each derivative with respect to x there, so they should match. F of x, y, y prime, all the way up to y to the n minus 1. So general form is where you just have your entire differential equation set equal to 0. The normal form is where you have the highest order derivative by itself set equal to the rest of the equation, all right? And that's why we have y sub n minus 1. This is not, that's the second highest order. There's the first, so that's by itself. All right, so two forms, general form, the normal form. And the last thing we're talking about is classification of linearity. An nth order ordinary differential equation is linear if f is linear in x, y, y prime, all the way up to y to the n minus 1. This means that it can be written as a sub n x of x, nth order derivative of y with respect to x. And then you have a sub n minus 1 of x. And so all of these coefficients with the derivatives, are a sub n of x, these are really functions, all right? And these are all functions of x. So in order for it to be a linear differential equation, for all of our derivatives, what needs to be in front is a function of x, or it could be a constant, all right? So, like a 5, or, so coefficient of 5, plus a sub 0 of x, y. And here, notice your y here is still times a function of x, and this y is to the first power, is equal to another function of x. So all these, the values, or the terms in front of your derivatives have to be functions in terms of x. If it's not a function in terms of x, if it's a function in terms of y, and you're taking the derivative with respect to x, then it's not going to be linear. So two key characteristics of ordinary differential equations set to be linear. All right, the dependent variable y and all its derivatives are the first degree. The power of each term involving y is 1. The coefficients a sub 0, a sub 1, a sub n are either constants or depend only on the independent variable x. All right, so we'll go over a few of these, how we can tell if they are linear or not. So again, the dependent variable y and all of its derivatives are of the first degree. So I can't have, like the previous example, the first derivative to the 7th power. That's not going to be linear. All right. Well, let's just go over a few examples and you'll see why. All right. So example 4 is the following a differential equation linear. And so we're looking at this. We have x plus sine of x, y double prime minus e dx y prime plus y equals 3. And we want to know if that differential equation is linear or not. So we look at all of our, first let's look at y double prime to the first power, y prime to the first power, y to the first power. So that checks off for the first part. The second part, all of our coefficients, are they going to be functions of x? In this case, yes, that's a function of x, minus e dx is a function of x plus y, so a constant of 1 equals 3. So yes, this checks out. So number 1 is linear. It is a linear differential equation. All right, 2. 1 plus y prime minus 2y equals sine of x. We first check our derivatives in our y. That's the first power, that's the first power. So we're good there, but notice the coefficient of y prime. It has 1 plus y, so it's a function of y in front. That's not linear, so it has to be nonlinear. Again, that term, the terms in front of your derivatives have to be functions of x, or have to be functions of the independent variable. All right, so look at 3. All right, I have x squared plus y dx plus 2x dy equals 0. Right now, it's not written in differential form. And so, again, because x is our dependent variable, what we're going to do is we're going to divide the whole equation. So this entire equation, we're going to multiply by 1 over dx. So that way we can have it in differential form. So then this is going to give us to the right, when I multiply 1 over dx, this first term, the dx's are going to cancel out, and I'm left with x squared plus y, and then plus 2x dy times that. So that's going to be dx times dy over dx equals, and then 1 over dx times 0 is just going to be 0. So now it's in differential form, where we see our derivative is dy over dx. And so when we're looking at this, okay, I have one derivative right there. It's of the first order to no power, so that checks off. And then there's my y value, and that's to the first power, so that checks off. This has a function, a term in front, a coefficient of 2x, which is checks off. And then this y that's to the first power, it has just 1 in front of it, so that's fine. We have x squared there. We could move it to the other side if we wanted to, but everything checks off for this to be linear. All right, let's look at the fourth one. All right, so here we have a third order derivative of y with respect to x. It's to the first power, so that checks off. Plus y squared, up, can't have that y squared. That needs to be y to the first power, so that does not check off, so that's non-linear. All right, 5. The fourth derivative of y with respect to x, that checks off because it's a fourth derivative, but to the first power, minus cosine of y. Cannot have cosine y. It needs to be y to the first power in order for it to be linear. Since it's cosine of y, it's non-linear. All right, so more than likely the first assignment that you're going to have for this class is going to be like a question 4. Example 5, classify the following differential equation by order, type, and linearity. So for 4, we have a second order derivative of u with respect to r, plus a first order derivative of u with respect to r, plus u plus cosine r plus u. So when we're talking about the order first, our highest order is the second order. So we have a second order derivative. So second order. Type, what type of, is this partial differential equation or ordinary? Since they're both respect to r, and r's are independent variable, it is a ordinary differential equation. So I'm just going to put ODE there for ordinary differential equation. And linearity, well, is this linear or not? Since it's the independent variable is r, and u is our dependent variable, so this left side checks off. Everything looks good because we have u to the first power and all of our derivatives to the first power. But then we have cosine of r plus u. Because u is inside of cosine and u is the dependent variable, that's not linear, so it's non-linear. And so, for our example, second order ordinary differential equation, non-linear.